Hi, welcome back. Now I am going to explain you first chapter of our M1, that is matrices. In matrices, first we need to know basics of matrices. So basics of matrices, first what is the definition of matrix? Matrix is called the arrangement of a well-defined objects or numbers or elements in a rows and a columns. And rows are the horizontal lines and represented using N, and the columns are the vertical lines represented using M. For example, A is our matrix and the numbers are 1, 5, 7, 3, 2, 4, 5, 9, 8. The well-defined numbers or well-defined objects which are arranged in rows and columns. These are called rows. These are called rows, and where the vertical lines are called columns. Okay, the arrangement of well-defined objects or numbers arranged in rows and columns is called our matrix. And next, rows, there are 3 number of rows, right? So rows is equals to 3 numbers. There are 3 rows. And next, columns are also 3. So, and writing the order, if we write 3 by 3, bottom right of our matrix, if we write 3 by 3, which indicates the order. Order is 3 by 3. Order is defined as number of rows by number of columns, which is written as n by m. We have to read it as n by m, where number of rows by number of columns means number of rows into number of columns. Okay, this is order of our matrix. Next, coming to the example, the order. Let us take A as a matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our matrix of order 3 by 3. Okay, and next let us take a matrix B, 1, 2, 3, 4, 5, 6. This is a matrix of order 2 rows by 3 columns, 2 by 3. So matrix appudu square matrix అనేవాడు కాదు, it may be a square or rectangular, no problem. Square matrix, rectangular matrix avanni nenu next types of matrices lo explain chestam. Into types of matrices, we know what is matrix type. Now types. In that, first is a very important, which is a square matrix. Square matrix, and the second one is a rectangular matrix. Okay, and next third one is a unitary matrix or unit matrix. Third one is our unit matrix. Next, if I open again, next వేరే types అంటే ఆ types చెప్తా. Coming to square matrix. Square matrix అంటే ఏంటి? Square matrix అంటే matrix of order n by m, where n is equals to m. N and m should be same. Okay, this is called a square matrix. Matrix of order n by m, where n is equals to m. For example, 1 0 0 1 is our matrix. Okay, and the order is 2 by 2, where it has 2 rows and 2 columns. This is called 2 by 2. So 2 by 2 matrix is called square matrix because n is equals to 2 and m is equals to 2. So if rows and columns are same in the matrix, in matrix having the same rows and same columns, same number of rows and same number of columns unte, here 2 rows ఉన్నాయి 2 columns ఉన్నాయి కాబట్టి 2 by 2 is our square matrix అనొచ్చు. Next, or 2 by 2 అని ఉండాలని కాదు, 3 by 3, 4 by 4, 5 by 5 A1 ఉండొచ్చు. అప్పుడు అట్లా number of rows and number of columns రెండు సేమ్ ఉంటే then it is square matrix. Okay, clear? Next, coming to rectangular matrix. Rectangular matrix అంటే opposite, contrast to the square matrix అంటే matrix of order n by m, where n is not equals to m. n m కంపల్సరీ రెండు సేమ్ ఉండాలని రూల్ లేదు. It may be of any order. For example, 1, 2, 3, 4, 5, 6 is our matrix of order 2 by 3, where we have 2 columns and 3 rows. So 2 by 3 is our matrix. So n is not equals to m. Is it right? N is not equals to m. Then it is a rectangular matrix. 2 by 3 gaani, 3 by 2 matrix gaani, 3 by 2 ante 3 rows. Like 3 by 2 matrix ki 1, 2, 3, 4, 5, 6, where we have 3 rows and 2 columns, where 3 by 2 matrix. So this is also a rectangular matrix. Next, unit matrix. A matrix having one as a principal diagonal number. Matrix having 1 as a principal diagonal number ante principal diagonal first matrices lo. Let us take that this is matrix of 3 by 3 of 3 rows and 3 columns. Okay, what is the principal diagonal ante 1 0 0 0 1 0 0 0 1. This one is called the principal diagonal. Principal diagonal starts from top left to bottom right. Okay, starts from top left to bottom right, where element having ij, let us take an element aij, where I is equals to j. What is aij? Aij ante endi ante a11. Suppose take I and j as a 1, a11, which gives matrix A, first row, element of first row and first column. Okay, first row, this is first row and this is first column, having 1 as its element. Next, take A22, second row, second column, second row, second column, this. So having 1 as its. Next, A33, third row, third column, 1. So unit matrix is a matrix having 1 as a principal diagonal. Principal diagonal ante endi starts from top left to bottom right, and A and J are equal. Diagonal laka. Okay, square lo diagonal draw chesi etla draw chestamo, but it is only starts from top left to bottom right. Anni 1 unte danni manam principal diagonals antam. Principal diagonal ante starts from bottom left to top right to bottom left. Okay, I J equal untadani. Elements having I and J are equal are called principal diagonal elements. Okay, principal diagonal elements. But coming to unit matrix ante unit matrix ante having 1 as a principal diagonal numbers and other elements are 0. Meeta elements anni 0 undali. So this is called unit matrix. Okay, yeah. And all other non-principal diagonal elements ఉంటాయి కదా, like ఇవి ప్రిన్సిపల్ డయాగోనల్ ఎలిమెంట్స్ కాకుండా నాన్ ప్రిన్సిపల్ డయాగోనల్ ఎలిమెంట్స్ ఉంటాయి కాబట్టి అవి మనకు 0 అంటాం. అవి 0 ఉండి ప్రిన్సిపల్ డయాగోనల్ ఎలిమెంట్స్ 1 ఉంటేనే దాన్ని మనం యూనిట్ మ్యాట్రిక్స్ అంటాం. క్లియర్? నెక్స్ట్ కమింగ్ టు నెక్స్ట్ టైప్స్ ఆఫ్ మ్యాట్రిసెస్. Fourth one is our triangular matrix. Upper triangular matrix, so there are two types, upper triangular matrix and the lower triangular matrix. Okay, fourth type is of triangular matrix. In this we have two types of matrices. First one is upper triangular matrix. And the second one is lower triangular matrix. Okay, upper triangular matrix and the lower triangular matrix. Upper triangular matrix ante principal diagonals. We know what is the principal diagonals, right? తెలుసు మనకు. So all elements below the principal diagonal are 0. Okay, and we know in unit matrix principal diagonal elements are 1, But in a triangular matrix, it should not be 1. It compulsory 1 undalani kaadu. It can be 1 or it cannot be 1. 0 kuda undochu, no problem. But principal diagonal elements kinda unna prati oka elements should be 0. I will explain with an example. Let us take a matrix of A. 1, 2, 3, 4, 5, 6. Okay. This is our matrix ordered 3 by 3 order. Next, this is our principal elements. Okay, this is our principal diagonal elements. 1, 4, 6 are our principal diagonal elements, and all elements below this, below the principal diagonal, are 0. Have you observed? All elements below this principal diagonal elements are 0. This is called upper triangular matrix, and the elements which are above the principal diagonal need not be 1. It can be anything, any numbers, but 1 is not compulsory. 1 undalani kaadu, a1 undochu. Principal diagonal kana kinduna prati oka element 0 undali. 0 untane manaku upper triangular matrix ani antamu. Okay, coming to lower triangular matrix. Lower triangular matrix in the contrast, same. Elements above the principal diagonal are 0. Okay, it should be 0. R0, it should be 0. Okay, elements above the principal diagonal are 0. Let us take with an example matrix A. Same, 1, 2, 3, 4, 5, 6, 3. Okay. This is our matrix of order 3 by 3. See, matrix of order 3 by 3, where this 1, 2, 3 are our principal elements, right? These are the principal diagonal. 1, 2, 3 are our principal diagonal elements. So above principal diagonal are 0. All these elements are 0. This is called a lower triangular matrix. Clear? Next, coming to row matrix and the column matrix. Next, coming to row matrix and the column matrix. It's our fifth type, row matrix, and next column matrix. Clear? Row matrix and the column matrix. Next, fifth one, row matrix ante row matrix ante elements, the matrix having only single row. It is having only one row, single row. Matrix having only single row. Row is our horizontal line. So for example, A, 1, 2, 3. This is our row matrix. It has only one row and 3 columns. 1, 2, 3. 3 columns, right? So 1 by 3 is our matrix. Row matrix is a matrix having only single row. Column matrix, matrix having only single column. Single column. Oh. Let us take a matrix B anukundam. B ki only okate column undi. 1, 2, 3. This is our matrix having only single column. Okate column undi, 3 rows unnai. Okay? 3 by 1 is our order. Next. This is our example of column matrix. Row matrix ante endi, column matrix ante endi. Is it clear? Next, coming to scalar matrix. I hope you guys have clear understanding clear. Next, scalar matrix. This is our 7th type, I guess. 1, 2, 3, 4, 5. Yeah, it's our 7th type. Scalar matrix. A square matrix. A square matrix having same diagonal elements. Same diagonal elements and 0 as non-diagonal elements. Okay, a square matrix having same diagonal elements and the 0 as a non-diagonal elements, where non-diagonal elements are the elements other than diagonal elements. For let us take an example, A matrix 4 0 0 0 4 0 0 0 4. Okay, the diagonal elements are this, right? These are our diagonal elements. Next, all diagonal elements are 4. I mean A11 is equals to A22 is equals to A33 as a 4. Okay, all are identical, all are same. Next, all non-diagonal elements are 0. So this is called our scalar matrix. Is it clear? Yeah. Eighth type is a symmetric matrix. To understand symmetric matrix, you need to know what is a transpose of matrix. Okay, first you need to understand what is transpose of a matrix. Transpose. To understand the symmetric of a matrix, you need to understand what is transpose of a matrix. Transpose. Consider a matrix A of order 3 by 3. Sorry, let's take order 2 by 2. 1, 2, 3, 4. This is our matrix A of order 2 by 2. If we perform transpose means interchanging the rows and the columns. Rows are changed to columns and the columns are changed to rows. Okay. So consider first row is changed to first column, second row is changed to second column. Okay. This is called our transpose of a matrix. Symmetric matrix is called first transpose of a matrix. Ante rows ni columns ni rows laga marchute manam danni transpose of a matrix antam. Okay, idi 1 2 3 4 matrix elements. Ee danni manamu first column ni first row loki esam 1 3 ni first column 1 3 kada adi row laga change cheste 1 3 row aitadi. Itla interchanging the rows and the columns is called transpose of a matrix. Coming to symmetric of a symmetric matrix, this is our eighth type. So symmetric matrix ante when we perform A transpose, again it should give as a. Okay, after performing a symmetric of a matrix A transpose, again we have to get A as its matrix. Okay, for example, let us take matrix of A of order 1 7 6 2 3 4 4 2 3 4. So this is our matrix A. If we perform A transpose perform jese first row is changed as a first column, second row is changed as a second column, third row is changing as a third column, right? Now compare, this is our order 3 by 3 and again this is order 3 by 3. ఇప్పుడు కంపేర్ చేయండి. ఫస్ట్ రో A ట్రాన్స్పోజ్ కి A కి ఏమైనా చేంజెస్ ఉన్నాయా? లేవు. బికాస్ 3 3 4 4 4 2 2 4 4 all elements are same. So after performing a transpose of a matrix చేసినాక కూడా elements same అలాగే వస్తాయి, arrangement of elements is same without any changing, then we can call it as a symmetric matrix. A transpose is equals to A is called a symmetric matrix. Next coming to skew symmetric matrix. Skew symmetric matrix అంటే ఏంటి? Skew symmetric matrix అంటే same as a symmetric matrix but a small difference. Consider a square matrix. When we perform A transpose, we are getting as a minus A as a skew symmetry, minus A as our resultant. Okay, A transpose చేసినప్పుడు అది minus A లాగా వస్తుంది. Okay, then this is called skew symmetric matrix. Transpose అంటే ఏంది? Interchanging the rows and the columns, right? Transpose of a matrix అంటే rows and the columns interchange చేయడం మనకు transpose of a matrix అంటాం. Next example తీసుకొని explain చేస్తాం. Skew symmetric matrix అంటే consider a square matrix అన్నాడు. So square matrix can be 1 2 3 4 minus 4 0 0. No problem, 0 can be a negative or positive, it doesn't have any sign కాబట్టి minus 5 5. Okay, this is our 3 by 3 matrix. When we perform A transpose of this matrix, A transpose perform చేస్తే అప్పుడు మనకి ఎలా చేంజ్ అవుతుంది? 1 4 0. Okay, row is changing into column, right? Next second row minus 4 2 minus 5. Next third row third column 0 5 3. This is our A transpose. Now compare A transpose and minus of A. Minus of A. A transpose is equals to minus of A. A transpose of, like, let us take elements minus 4, okay? Square matrix where we will perform A transpose equals to minus A. The principal diagonal elements will not change, okay? Principal diagonal elements will not change. It will be constant. But when we perform, because why it will be constant? Because transpose of a matrix perform చేసినప్పుడు rows columns చేంజ్ అయినప్పుడు కూడా మనకు ప్రిన్సిపల్ డయాగోనల్ ఎలిమెంట్స్ విల్ నాట్ చేంజ్ అన్నమాట. మనకు అదే ఆర్డర్ లో వస్తుంది. సో సేమ్ వే ఏ ట్రాన్స్పోజ్ పర్ఫామ్ చేసినప్పుడు కూడా మనకు ప్రిన్సిపల్ డయాగోనల్ ఎలిమెంట్స్ ఒక సైన్స్ కూడా చేంజ్ కావు. బట్ ఓన్లీ దిస్ minus of A అవుతుంది. A transpose equals to minus of A. How can we cross verify అంటే let us take an element of minus 4. Minus 4 ఒక ఎలిమెంట్ ట్రేస్ ఏంది A12 కదా, ఫస్ట్ రో సెకండ్ కాలమ్. సో let us consider A12 ఫస్ట్ రో సెకండ్ కాలమ్ as a minus 4. Minus 4 elements as a in A transpose. అది A లో A matrix, this is our A matrix, right? Matrix A లో first row second column is our plus 4. ఏమంటుండు మైనస్ 4 మైనస్ ఏ అది వస్తుంది అంటుండు. సో మైనస్ ఆఫ్ 4 వేర్ మైనస్ 4 is రెండు సేమ్ కదా. సో ఏ ట్రాన్స్పోజ్ ఈక్వల్స్ టు మైనస్ ఏ వస్తే దాన్ని స్క్యూ సిమెట్రిక్ మ్యాట్రిక్స్ అంటాము. ఏ ట్రాన్స్పోజ్ ఈక్వల్స్ టు ఏ వస్తే దాన్ని సిమెట్రిక్ మ్యాట్రిక్స్ అంటాం. దిస్ ఈజ్ about symmetric and the skew symmetric matrix. Transpose of a matrix is interchanging of rows and the columns. Next, coming to Hermitian matrix and the skew Hermitian matrix are the two types left over. Hermitian matrix lo first we need to understand what is conjugate of a matrix. Okay, conjugate matrix. Conjugate of a matrix అన్నప్పుడు ఏంది? Conjugate matrix అంటే ఏంది? Simple. Conjugate matrix is a considered matrix with a complex numbers. Complex numbers are always defined using I అనే వేరియబుల్ తో మనం కాంప్లెక్స్ నెంబర్స్ ని వాడతాము. సో కాంజుగేట్ matrix are matrix having complex numbers. Matrix of a matrix having complex numbers is called conjugate matrix. Example, A has a 3, I minus 1, I plus 1, 5. This is our conjugate matrix. Okay, because we have minus I and I as our complex numbers. Okay, now Hermitian matrix. Hermitian matrix ante, and conjugate matrix is always defined using, represented using A bar. A bar is equals to conjugate. Conjugate matrix ni A bar tone represent చేస్తాం. సో conjugate Hermitian matrix అంటే ఏంటి? A is equals to A conjugate transpose of A conjugate. First we need to consider A as a matrix. Now Hermitian matrix తెలవాలంటే ఫస్ట్ మనకు కాంజుగేట్ మ్యాట్రిక్స్ తెలవాలి. వాట్ ఈస్ కాంజుగేట్ మ్యాట్రిక్స్? కన్సిడర్ ఎ మ్యాట్రిక్స్ విత్ కాంప్లెక్స్ నెంబర్స్, having a complex number of matrix. Matrix A has a 3 minus 1 minus I, 1 plus I, 5. This is our matrix A. Conjugate matrix is always represented using A bar. So now to get a conjugate matrix of A conjugate రావాలి అంటే replace minus I as a plus I, or I with a minus I as a plus I, or plus I as a minus I. Okay, 3 I plus I minus I, 5. This is our conjugate. Replacing I as a minus I. Replace I minus I. Positive I unte negative I aitadi, negative I unte positive I aitadi. Okay, replacing of i's annamata. I ante in the imaginary numbers or complex numbers. Hermitian matrix ante endi? Hermitian matrix ante A transpose of A conjugate. A transpose of this conjugate matrix is equals to A. Okay, let us take an example and I will explain you clearly. Consider a matrix A as 1 minus I, 1 plus I, 3. Okay, this is our matrix A. Now perform A conjugate find A conjugate matrix. A conjugate and replace I with minus I. So minus I is represented with I. So I minus I change it to I plus I plus I change it to A minus I, 3. This is our conjugate. Now performing transpose of a matrix. Again transpose, A conjugate transpose. Transpose is interchanging rows and the columns, right? So 1 minus I, 1 plus I, 3. This is our conjugate of a transpose of a conjugate matrix. Now compare A and the A is equals to A conjugate transpose. Transpose of a conjugate matrix are equal. This is called Hermitian matrix. Simple. Next, skew Hermitian matrix. Skew Hermitian matrix is skew Hermitian matrix. Skew Hermitian matrix is dead opposite to matrix. Hermitian matrix, okay? A conjugate transpose is equals to minus A. It is simple as a skew symmetric and the symmetric matrix, as a Hermitian and the skew Hermitian matrix. When we perform transpose of A conjugate, then we are going to get minus A as its resultant. Okay, this is called Hermitian matrix. This completes our basics types of matrices. Now, next 3 types. This completes our types of matrices. These are the only 3 types left over. Next, idempotent matrix. Idempotent matrix ante A square equals to A. A square ante multiplications of A. A is multiplied by itself, then we are going to get again as A as a resultant matrix. This is called idempotent of a matrix. Okay, A square equals to A is called idempotent. Coming to nilpotent. Nilpotent is called A power k equals to 0, where k is any positive integer. A is any positive, k is any positive integer is called nilpotent. Next, involuntary. Involuntary matrix is A square equals to I, where when we perform A into A multiplication, then we are going to get unit matrix as a resultant matrix. Unit matrix is represented using I. This is called A square as I. Involuntary matrix is A square as I. Nilpotent matrix A power k is 0, where k is any positive integer. Next, idempotent matrix A square equals to A. A into A is A. Okay, this completes our types of matrices. Next topic is trace of our matrix. Trace of a matrix. Trace of a matrix ante a square matrix. A square matrix sum of all diagonal elements. Okay, sum of all diagonal elements is called our trace of a matrix. Let us consider A as a matrix 1, 3, 4, 2, 5, 6, 3, 4, 5. This is our matrix, A matrix of order 3 by 3, right? Sum of all diagonal elements are called trace of our matrix. So what is the diagonal elements? What are the diagonal elements are? 1, 3, 4 are called diagonal elements, right? Diagonal elements. So trace of a matrix. Trace of a matrix A is equals to 1 plus 3 plus 4, which gives the answer 3 plus 4, 7, 7 plus 1, 8. So trace of a matrix is 8. This is called our trace of a matrix. Okay. Thank you.